And what about you? A 2006 Grand Cherokee, ABS fault. ABS is pulsing, only now and again, drive it for a while and the ABS light comes on. Pulled some codes and we have a fault for the rear left speed sensor. But this is a Jeep and this is known that these sensors work a wee bit differently from the usual ones, you know. I did this wee video a few months back, I think it was about March time, and it was basically running through different types of weed speed sensors, and I showed a wee test tool you can make and how you can test them. So there was a few different types there, and we talked about the VRS, the Hall effect, and the one at the end was the magnetoresistive. Now, I never really went into the magnetoresistive sensor an awful lot, and probably because I didn't have one. Well, I did have one, it was a Mercedes one, but it was a failed sensor, so there's nothing really you could do with it. So this Jeep has a magnetoresistive sensor on it, and it functions completely differently from stuff that you may have seen before. So we'll do a wee quick recap. If you haven't seen that video there, it's maybe worthwhile watching that before we go into the rest of this, because it might make an awful lot of sense. So there's a good few comments here from the usual guys that comment, which is very much appreciated. Great explanation. There's a very marvelous compliment there. It's that was the best ABS sensor test and demonstration I've seen. So that's a compliment there and a half. But the one that stuck out for me, and all these are great, of course. Russell, first class stuff. Is Stephen there? Stephen Casabis. I hope I'm pronouncing that right. That guy's in Australia. Maserati Quattroporte ABS sensor cost in Australia $2,000. My goodness. So this one here stands out to me. This, just to let everyone know, magnetoresistive sensors is not new. In fact, Alfa Romeo used this magnetoresistive for their speed sensor back when they made the Alpha 33 in the 90s. So that's brilliant information there from Stephen. These magnetoresistive sensors, it's not that these are the future. They've been around all the time. It's just a different way of doing it, and it's very, very accurate. And we'll see that as the video goes on. But it worked completely different from a Hall effect. We'll do a quick reminder of the different types of sensors and how this magnetoresistive sensor here functions. Right, so a wee quick review is these are the sheets I demonstrated the last time. So there's the VRS one, variable reductive sensor. That's known as a passive one because it generates its own voltage. This is known as the active one. It's 12 volts in, produces a square wave from 0.8 to 0.6, and the speed is determined by the frequency. And you can have those two on a tone ring or on the magnetic ring there. So either or, doesn't make any difference. It's still a Hall effect. But the last one is the magnetoresistive. Now it's shown that they're on a magnetic ring, but it's same as the Hall effect. You can have the magnetoresistive in either the tone or the magnetic ring. So just to give you a wee bit more info on that, is okay. Hopefully we can read this here. But yeah. The sensor is mounted above a magnetic coder. Now it can be a tone ring as well. The resistive properties varying in accordance with the magnetic field presented to it. As a result, the variation of the internal resistance of the center, the velocity and direction of rotation can be established. Now, so the important bit there is the internal resistance of the sensor varies with the magnetic field. That's how that works. So you put 12 volts on it. Well, it's usually about 11.5, something like that. It's a wee bit less than battery voltage, and what happens then is when it's acted on by a varying magnetic field, the internal resistance changes. So the current flow through that sensor then creates a very, very small amount of current, and that's what the ECU is actually determining the speed is. So we'll have a wee look at that. So we did a full scan of the vehicle with the hotel there. That's the 06 car there. And so left rear tone wheel performance there in the ABS, implausible data from the ABS. He needs a glow plug and implausible left rear wheel speed signal, and they're stored. And yeah, so if the car's not moving, the fault isn't there. That's pretty good. That tells us that it's unlikely we'll have a wiring issue. So it's getting implausible data from the left rear. So that's what we're going to look at. So went for a wee drive and recorded some data, and the fault wasn't there initially. So down here we can see we recorded 13.35 seconds. So if we speed this on, we can see the rear left and rear right pretty even. Let's go screw it on a bit here. I'm just moving this wee cursor with my finger here, and all looks pretty good. So we're at 8 minutes into the drive, and 9 minutes, and oh, there's our left starting to act up here. We can see there's another wee glitch, another glitch, and there. So if we compare the two signals there, we can see the left there is indeed acting up. So I'll pull that up. Yeah, so we can see it there dropping out. And if we compare that with the other one, so that's what we're going on. So my suspicions is that this is a magnetoresistive sensor. We'll have our breakout leads in there, and we'll just see what we can see there. You can just about make out that's the harness side, and we'll have the breakout leads in the connector there. Green wire seems to be is positive, and black is ground, and we'll have that connected in to our wee Vantage Pro there. And this is an all-wheel drive vehicle, and the turning this thing is pretty stiff, but we can put the wheel back on and do more testing. So we can see a fluctuation in the voltage there. I'll just show you what way that was connected there. So this is the harness side of the car. It's a green coming into the connector that's on the body of the car, and a black. So I put my breakout leads in. I just used the same colours, green and black, and took them out. So we'll have these are connected here and here, so we still have it straight through to the sensor, but we're breaking in with the voltmeter with the Vantage Pro. And as we saw on the positive there, we got 11.02 volts, and when we rotated the reluctor ring or the tone ring, it went up to 11.07. So 0.05 of a fluctuation there. That is a good test, because that tells me right away that my harness wiring is good. Okay, I've just put the wheel back on again loosely so I can give this a good old spin here, and I have the y-axis here on 10k there, and you can watch the voltage fluctuate yourself. So we're going to look for our dropouts, see if we can spin this sort of evenly. And yeah, look at that graph, it is dropping out pretty badly. Lots of dropouts there. So at low speed and with that magnified, we're going to drop it out. So that's good. I thought I was going to have a problem replicating this fault, but so does look like a new sensor, but we'll see if we can make sense of these this voltage here. Right, so we're going to graph this voltage here, and I'm going to give this wheel a spin as hard as I can. So it's quite humid in here, so this might take. Let's see what I can do here. Let's see if we can watch the voltage, and it's very, very small difference. That's when it's spinning when it comes to rest. It sits there. So the actual voltage level, it goes up and goes down. You can see it there in the visual, but you can't see it there on the, you're not seeing anything at all on the voltage there. So what we can do with a revantage is we can change these settings here. So what we can do is put it on AC coupling. So what that does, and if you use scopes, that takes out the DC component, and it'll just show the difference, the AC fluctuation. So it's like the pulse. It'll just show the pulse. So that's all we're interested in. So we'll have to change our scales here. What I'm also going to do is put the filter on there as well. Now, so the difference in the voltage is like a volt, not half a volt even. So we're going to change that to a volt, and that's on to just a trigger, right? Okay. So I need to bring a trigger right down there, and what we'll do is we'll give it a go for a second there, because I can't spin it very fast. So say this car's all-wheel drive, so it would have been great if it was just back-wheel drive. We just left it wrong, but I have to spin it here. So let's see what we get there. So that is purely the difference. That's with the nominal 11 volts gone, and it's just going to show us the difference there. So we'll bring that up a wee bit. But it's not much use to us, that signal, because we can't really see any glitches. We can see it in the scan tool, but I would like to see something a wee bit better. So we're not seeing really dropouts there. This is a good signal there, and yeah, you can see it's a bit hashy, but is that good? Is that normal? I'm not too sure. Well, anyway, these magnetoresistive sensors, it doesn't actually work on voltage. That's just a test. You know, it just checks to see if your wiring's okay. What the computer is actually looking at is current. So it doesn't really matter what wire you put it on, because the current flows in, current flows out. So the same current flows on the positive and then goes out back out on the ground again. So I'm not sure whether it's actually looking at the current on the ground or both. It may actually be looking at what direction the current is flowing, for whether the wheel is going in reverse or forwards, because these some of these magnetoresistive sensors for hill holders, it's bidirectional. So we're going to set up a wee current trace now. So the way I'm going to set the vantage to measure current, we're going to use amps internal. So we used another one of the breakout leads in the bunch there. It just chose the yellow one. We kept the green one in, and the black goes straight through, so that's a solid connection still. So the green then went into the Vantage Pro, and then the yellow one came out of the Vantage Pro and into the sensor connector. So when you select amps internal on the Vantage, or if you're measuring amps internal through a DVOM, it connects it through. So that makes that a solid wire again. So that's how I'm measuring the amps there. And we rotate the reluctor ring, and we can see our milliamps it is in this case. So I need to change the Vantage for amps internal, so I need to swap this lead for the amps there, 32 or 32 volts, 10 amps max in this. But this is millivolts here. So I'll get you set up. There we go, that's not bad. So amps internal, and the wee voltage here, the lowest it'll go is 100 milliamps there. So we'll be able to see something. And as we can see, it's showing 9 milliamps. So I'm just going to give this, of the wheel off, and I'm just going to give this a just very gentle return here. We can see that happening. So it's reading 16 milliamps there. So it seems to go between 9 and 16 or 17 milliamps. So very, very little. So your inductive amp clamp and stuff won't pick this up unless you put an additional colour in it. But this is just for to show what way this is reading the signal. It's not the voltage, it's this current here. So the tiniest wee movement, we can see it changing there, and that's it back down to 9. Now, so the difference in the number is whether it's on a peak or a trough of the tone ring. So I can just move this very slightly. We can see as it moves across the tone ring, I'm just touching that. So I'll just show you what way I'm doing that. So this is what I was doing there to get that current to change. I was just doing that. So that's a peak, it's a trough, that's a peak, that's a trough, that's a peak, that's a trough, that's a peak, that's a trough, that's a peak. Now let's see if we can get the both in shot at the same time there. So there's it reading 17 milliamps, and it's on a trough there by the looks of it. So we've just moved that a wee bit. Down to 9. So you see how accurate that is? And it doesn't look as if this detects reverse in this type of sensor. So if we go the other way, it's just peaks and troughs. So that's a peak at 9 milliamps. That's a trough at 17. Just focus in on the electro ring there. We'll go back onto the vantage. You can't really see it. So we'll give it a bit of a spin. Let's go backwards. We'll do it forwards. And that's our current. So I want to see this glitch, and I'll maybe get something with a bigger screen and just go back to the voltage measurement. This is the only thing I have apart from an ordinary DVOM that'll measure amps internal, and even at that it doesn't go down really low enough. So I mentioned in that clip that the current flows through the sensor. So as we saw from the description, the changing internal resistance, which is acted upon by either the magnetic ring or the magnets inside this, changes the current that flows through. And that's why, as I say, I mentioned that you'll see the current on the positive and on the negative. So I haven't done enough testing as yet to see what direction this current flows, and that may be how you get the directional indication. So it's direction of current flow. I suspect that's how it does it, but I'm not 100% sure. I need to do more testing on that aspect of it. But for this video here and this fix, I need to go ahead with the repair. Customers waiting in this car, so I don't want to labour this too much. Okay, we're back on the live data here, and I'm spinning the wheel and just dropping out like crazy there. So I've set up the wee Pico, and let me take a wee capture there of the volt. We're back on the voltage again, incidentally. Okay, I'm going to run the Pico and I'm spinning the wheel. I can see a couple of dropouts there on the live data. So I'm not spinning it very fast, only doing about 3k there. We'll see what we get. Stop that. So let's see, with 200 milliseconds per division, that's the best that I could get this. And I'll give it a wee zoom in. See if it's going to show us anything. Okay, so that's the voltage there. You see it maybe over to the left is 12 volts there, roughly. So we're not really seeing any dropouts there. The way I did the live data, I'll just bring it. There's only 2 or 3. Looks pretty even, that. So I'm going to AC couple this. So with the scope on AC coupling, and let's see if we can pick up a few glitches. So I'll just run that. And there's a capture. I'll try and spin the wheel here as even as I can. And I'm watching the live data and I can see it jumping down or dropping down, glitching out as I'm doing that. So there's plenty of downward spikes there. I know you can't see it, I know it's off camera. So stop that. And let's see what we've got here. We'll go back a couple of frames. And yeah, there it is. There's Glitch City there. So we'll give a wee zoom in that. So this is on AC coupling, as I said. There's it there, and that takes out the constant DC element. So it's quite useful when you're looking for changes, and you just get rid of the constant voltage. So I'll just zoom out again. You can see it better. Back a frame. I'll zoom out a wee bit more. Yeah, let's see that a bit better. So there we go. That's our glitching there. So okay, that's going to get a new wheel speed sensor, and we'll just keep this set up, and we'll run it with a good sensor on it. So that's our sensor out of the car. That's it there, and as we can see, it's a wee bit. There's a wee bit of grease on it actually. So because of this style, it's not completely round. It pops in and out dead easy. No troubles at all. That's the connector that I was breaking into with the breakout leads there. The wee pins, quite thick wee pins there, and that's it. The one I put in, if you want a part number, guys, that's the part number. You can Google that. That's for the rear. They're not sided. That does left and right on these Jeep Cherokees. That's an aftermarket make, pretty well respected. In the UK, it's a Febby Bilstein company, which is a German company, but yeah, that's part number. So new sensor fitted, easy enough in this car. Just clipping the cable into where the chassis is, a wee bit tight in your arm. So we're going to give this wheel a spin. Going to keep it as nice and even as I can. There's about 3.5 kilometers an hour, and with no dropouts there. So that's a scale on the y-axis there that goes up to 10 kph. You can put that, you can change that scale. So no big dropouts, that's what we're looking for. So we'll get the car back down and put the car back in the deck, take it for a test drive, take it for a good run, and we'll give it back to the customer. So hopefully you got something out of that video, and a wee bit more on sensors and how this particular one works. This Jeep one, I think it gets caught out by a lot of people when they're seeing the strange voltages and think that maybe have an open circuit in the signal wire. So many thanks for watching, all the best, and bye bye.